November the 2nd, 2025, 8 days ago. Avi Loeb appeared on Fox News and said something that stopped people mid-sentence. The Atlas might be a Trojan horse, not metaphorically, not as a casual comparison, as a literal warning about an object that looks like a comet on the outside but might be carrying something else inside. The city of Troy trusted appearances. They saw a wooden horse, a gift left behind by retreating Greeks, and pulled it inside their walls. It looked harmless. It looked like a victory trophy. By morning, Troy was burning. Greek soldiers hidden inside the horse had emerged during the night, opened the gates, and let their army pour in. Troy fell not because its walls were weak, but because its guardians believed what they saw. Loeb's warning is that we're doing the same thing. We see Atlas, we call it a comet, because it has a coma and reflects sunlight, and we assume it's natural because that's what comets are supposed to be. But appearances deceive, and by the time you realise the threat is already inside the walls, it's too late. On October 31st, 10 days ago, 2 days after perihelion, Loeb published a white paper with colleagues Omer Eldadi and Gershon Tenenbaum, warning policymakers about black swan events, catastrophic scenarios involving massive objects moving along strategic trajectories. The paper doesn't call Atlas artificial outright. Legal and diplomatic constraints prevent that kind of direct accusation without definitive proof. But it says governments should prepare for the possibility that we're wrong about what this object is. Because if we're wrong, and we do nothing, the consequences could be civilizational. The Fox News interview was on America's Newsroom, a morning program with hosts Bill Hemmer and Dana Perino. Loeb appeared via satellite from his office at Harvard, speaking calmly but urgently. The hosts asked him directly, "Is Three-Eye Atlas a threat to Earth?" Loeb's answer was precise, not a collision threat. The object will pass 267 million kilometers from Earth, far too distant for impact. But that's not the only kind of threat. The fundamental question is whether Three-Eye Atlas is what it appears to be, a natural comet, or whether it's something designed to look like a comet. A Trojan horse with the external appearance of natural phenomena but carrying capabilities we don't understand. The host pressed for clarification. "Are you saying it's a spacecraft?" Loeb deflected slightly, maintaining scientific caution. "I'm saying the data doesn't fit natural models cleanly. The object accelerated at perihelion without producing visible debris. It turned bluer than the sun, suggesting internal heat sources. It's moving along the ecliptic plane with precision that natural interstellar objects don't typically exhibit. These anomalies could have natural explanations we haven't thought of yet, but they could also indicate technology. And if there's even a small probability it's technology, we should prepare accordingly." The interview lasted 6 minutes, shorter than most cable news segments, but the impact was immediate. Social media exploded. Within hours, Trojan Horse was trending on Twitter. Reddit threads dissected Loeb's phrasing, analysing what he said versus what he implied. YouTube channels posted reaction videos, some mocking the idea as science fiction, others arguing the evidence supports it. Mainstream media picked up the story hesitantly, framing it as Harvard scientist warns about interstellar object, without committing to the Trojan horse language, but the phrase stuck. By the end of November 2nd, Trojan horse had become shorthand for the technological hypothesis about Atlas. The timing of the white paper, published on Halloween, October 31st, added symbolic weight. Halloween is about costumes, disguises, things pretending to be what they're not. Loeb didn't choose the publication date for symbolic reasons. The paper was ready and peer review had cleared it, but the coincidence resonated. Halloween fell 2 days after perihelion, the moment when Atlas passed closest to the sun and exhibited its most dramatic anomalies. The blue glow, the rapid brightening, the non-gravitational acceleration. These events occurred on October 29th, but we didn't learn about them until October 31st, when solar monitoring satellite data was analysed and released. So on Halloween, the same day we traditionally celebrate deception and disguise, we learned that Atlas had done something at perihelion that looked very much like it was wearing a costume. The white paper itself is titled Black Swan Events Involving Anomalous Interstellar Objects, Policy Implications and Preparedness Strategies. It's 14 pages, dense with references to orbital mechanics, statistical analysis, and historical case studies of unexpected threats. The core argument is that policymakers systematically underestimate low-probability, high-impact events because they're cognitively difficult to process. Humans aren't good at preparing for scenarios that seem unlikely even when the consequences would be catastrophic. We prepare for hurricanes because they happen regularly. We don't prepare for asteroid impacts because they happen rarely. But rarity doesn't mean impossibility. The paper uses 3i Atlas as a case study without naming it directly until page 7. It describes a massive object of interstellar origin moving along the ecliptic plane, exhibiting non-gravitational accelerations and thermal anomalies inconsistent with standard cometry models. It notes that such an object, if controlled, could theoretically perform maneuvers bringing it closer to Earth or other strategic locations in the solar system. It calculates the energy requirements for such maneuvers and concludes they're within the range of technologies a civilization only slightly more advanced than humanity could achieve. The policy recommendations are cautious but significant. First, establish continuous monitoring protocols for interstellar objects, not just during discovery and initial characterization, but throughout their passage through the solar system. Second, coordinate internationally to ensure no gaps in observational coverage. Third, develop contingency plans for scenarios where interstellar objects exhibit behaviors suggesting deliberate control. Fourth, avoid dismissing technological hypotheses prematurely based on assumptions about what extraterrestrial civilizations would or wouldn't do. That fourth recommendation is subtle but important. The paper argues that many scientists reject the technological hypothesis for Atlas, not because the data rules it out, but because they assume aliens wouldn't send probes disguised as comets, or wouldn't approach Earth this way, or wouldn't exhibit these particular behaviors. But these assumptions are anthropocentric projections. We don't know what extraterrestrial civilizations would do because we've never encountered one. Assuming they'd behave according to human logic or human expectations is unjustified. The data should drive conclusions, not assumptions about alien psychology. The paper also addresses the Trojan Horse scenario directly on page 11. It notes that reconnaissance probes designed to avoid detection would logically mimic natural phenomena. A probe disguised as a comet benefits from reduced scrutiny. Scientists assume it's natural and apply natural models, which fail to explain anomalies but don't immediately suggest artificiality, because natural explanations are assumed to exist even if not yet discovered. This creates a cognitive trap where anomalies accumulate, but each individual anomaly is explained away as unusual but probably natural, rather than collectively interpreted as evidence of design. Troy fell into this trap. When the Greeks left the wooden horse, Trojan scouts examined it. They saw wood, wheels, craftsmanship. It looked like a Greek construction, which it was. They assumed it was a gift or an abandoned siege engine, which it wasn't. The trap worked because the Trojans evaluated the horse based on surface features without considering the possibility of hidden interior functions. Loeb argues we're doing the same with Atlas. We see a coma. We measure reflected sunlight. We detect water and carbon dioxide. It looks like a comet, which it might be on the surface. But we're not adequately considering the possibility that beneath the cometry exterior, there's something else. The paper's co-authors bring relevant expertise. Omer Eldadi is a physicist specializing in orbital dynamics and spacecraft trajectory design. Gershon Tenenbaum is a psychologist who studies decision-making under uncertainty, particularly how individuals and institutions respond to ambiguous threats. The collaboration between an astronomer, a physicist, and a psychologist is unusual, but it reflects the interdisciplinary nature of the question. Determining whether Atlas is natural or artificial isn't just about analyzing data. It's about interpreting ambiguous data correctly, despite cognitive biases that favor familiar explanations over paradigm-shifting ones. The paper circulated rapidly through policy networks. By November 3rd, one day after Loeb's Fox News appearance, copies had reached NASA headquarters, the White House Office of Science and Technology Policy, the Department of Defense, and congressional committees overseeing space policy. Whether policymakers read it thoroughly or filed it away is unclear. But its existence legitimizes discussion of scenarios that would have been dismissed as fringe speculation a month earlier. A peer-reviewed paper, published by reputable scientists, saying, "Prepare for the possibility that this object is controlled," gives political cover to officials who want to take the threat seriously but fear ridicule. Public reaction split predictably. Skeptics dismissed the Trojan Horse idea as attention-seeking, arguing Loeb has a history of making provocative claims about Oumuamua and that he's doing the same with Atlas. They point out that extraordinary claims require extraordinary evidence, and the evidence so far, while unusual, doesn't definitively prove artificiality. Natural explanations for each anomaly might exist even if they haven't been discovered yet. Jumping to its aliens is premature and scientifically irresponsible. Supporters counter that Loeb isn't saying it's definitely aliens. He's saying the data is ambiguous and we should prepare for multiple possibilities, including the one that challenges our assumptions most. That's not irresponsible. That's prudent risk management. If Atlas is natural, preparing for it to be artificial wastes some resources but causes no harm. If Atlas is artificial, and we don't prepare because we assumed it was natural, the harm could be existential. Asymmetric risk justifies asymmetric caution. The debate played out in media appearances over the following week. Loeb did follow-up interviews on CNN, BBC, and several podcasts. Each time he refined his messaging. He emphasized that he's not claiming certainty about Atlas's nature. He's arguing for open-mindedness and preparedness. He compared the situation to buying insurance. You don't buy fire insurance because you're certain your house will burn. You buy it because if your house does burn and you're uninsured, you're ruined. Preparing for Atlas to be artificial is insurance. If it's natural, the insurance premium was wasted. If it's artificial, the insurance saves civilization. By November 10th today, the Trojan Horse framing has shifted the conversation. Media coverage that previously focused on Atlas as a curiosity now discusses it as a potential security issue. Congressional staffers have begun drafting questions for upcoming hearings with NASA administrators. Defense Department analysts are reportedly modeling scenarios involving controlled interstellar objects, and amateur astronomers preparing to observe Atlas tomorrow night, on November 11th, carry a sense of urgency that wasn't present before Loeb's warning. They're not just observing a comet, they're documenting a visitor that might be watching us back. Now here's why the Trojan Horse analogy fits so precisely it's unsettling. Atlas exhibits all the surface characteristics of a natural comet. It has a coma, the cloud of gas and dust that forms when ice sublimates under solar heating. It reflects sunlight in wavelengths consistent with cometary dust. It's moving on a hyperbolic trajectory, the path interstellar objects follow when passing through the solar system. To casual observation, to initial analysis, to anyone not looking deeper than surface features, Atlas is exactly what a comet should be. But beneath those surface features, the anomalies accumulate like soldiers hidden inside a wooden shell. The coma is real. Multiple observations confirm gas and dust surrounding the nucleus. Spectroscopy detected carbon dioxide, water vapour, carbon monoxide and organic molecules. These are standard cometary volatiles, substances expected when solar heating sublimates ice. The coma's size, several 100,000 kilometres in diameter, is typical for comets at Atlas's distance from the Sun. Nothing about the coma itself suggests artificiality. It's exactly what you'd design if you wanted something to look like a comet, which is the point. The Trojan Horse wasn't made of stone or metal, it was made of wood, the material Greeks used for buildings and ships, the material Trojans would recognise and trust. If you're designing a reconnaissance probe to avoid detection, you don't make it look like a spacecraft. You make it look like something natural. You give it a coma, but the coma doesn't explain the acceleration. On October 29th, at perihelion, Atlas accelerated in a way that shifted its trajectory measurably. By November 1st, the object was roughly 5,000 kilometers ahead of where purely gravitational models predicted. Natural comets accelerate too, driven by outgassing. Jets of gas escaping from the nucleus act like tiny rocket thrusters, pushing the comet slightly. Astronomers account for this by estimating how much gas is escaping based on the comet's brightness and activity level. For Atlas, the acceleration detected at perihelion requires outgassing rates far higher than the observed brightness suggests. If Atlas were outgassing enough to produce the measured acceleration, it should be much brighter, ejecting massive amounts of gas and dust that would scatter sunlight intensely. It should also be losing mass rapidly, shedding material that would form visible plumes extending millions of kilometers. Neither of these things was observed. Atlas brightened at perihelion, yes, but not by the factor of 10 or 20 that would be necessary to explain the acceleration through natural outgassing alone. And no large-scale plumes appeared in images from SOHO, Stereo, or GOES satellites. The acceleration happened without corresponding visible mass loss. That's inconsistent with natural comet behavior, but it's consistent with propulsion systems that expel exhaust efficiently or generate thrust through mechanisms that don't require visible material ejection. The blue color at perihelion is another layer. Natural comets appear reddish because organic molecules coating their surfaces absorb blue light and reflect red. When Atlas was first observed in July, it appeared reddish, exactly as expected. In early September, it emitted green light, also expected, caused by diatomic carbon and cyanogen molecules fluorescing under ultraviolet sunlight. But at perihelion on October 29th, observations from LASCO and GOES coronagraphs showed Atlas appearing distinctly blue, with colour measurements indicating it was bluer than the Sun itself. The Sun's photosphere has a temperature of 5800 Kelvin and emits light that defines what we consider white. Objects reflecting sunlight can appear redder than the Sun if dust scatters blue wavelengths away. They don't naturally appear bluer unless they are emitting their own light at temperatures higher than 5800 Kelvin. For Atlas to glow blue, it needs an internal heat source. Natural comets at 1.36 AU from the Sun have surface temperatures around 300 to 400 Kelvin, far too cold to emit visible light thermally. Even if the entire surface was sublimating explosively, evaporative cooling would prevent temperatures from reaching the thousands of Kelvin needed to glow blue. But fusion reactors glow blue. High-temperature plasma exhaust glows blue. Certain types of propulsion systems produce blue emission as a byproduct. The colour doesn't prove artificial systems, but it's consistent with them in ways that natural comet models struggle to explain. The nickel emission adds another anomaly. Spectroscopy in August detected nickel emission lines, wavelengths of light emitted when nickel atoms are heated and excited. Natural comets contain trace metals, including nickel, but nickel emission is rare because nickel has a high vaporization temperature. For nickel to emit light, it needs to be heated above 1500 Kelvin, temperatures comets don't normally reach. The fact that Atlas emitted nickel without corresponding ion emission, which should appear at similar temperatures, suggests the nickel isn't just trace contamination in the ice. It might be structural, part of a metallic surface or component being heated to high temperatures. The trajectory precision is perhaps the most damning feature. Atlas entered the solar system on a path aligned within 2 degrees of the ecliptic plane, the flat disk where planets orbit. Random interstellar objects approach from random directions. The probability that an object naturally arrives with an inclination below 2 degrees is about 2%. Atlas also happened to pass Mars on October 3rd at a distance optimal for gravitational assist, then position itself for a December 19th Earth approach and a potential January Jupiter encounter. Each individual event could be coincidence, but the combination, the sequence of planetary encounters along an ecliptic-aligned trajectory, has a combined probability around 1 in 20,000 if natural. Those are lottery-winning odds. You don't win the lottery unless you buy a ticket. And trajectories don't exhibit this kind of precision unless someone calculated them. Historical examples show that deception works when the disguise matches expectations. The Trojan Horse succeeded because it looked like something Greeks would build and abandon, something Trojans expected to see after a siege. If the Greeks had left a golden chariot or a marble statue, the Trojans would have been suspicious. Wood was mundane, familiar, non-threatening. Similarly, a comet is mundane. We discover comets regularly. Interstellar comets are rarer, but Borisov in 2019 was clearly natural, so the category natural interstellar comet exists in our mental models. When Atlas appeared, exhibiting cometary features, we filed it in that category. We expected it to behave like Borisov, and when it didn't, we invented natural explanations for each deviation rather than questioning the category itself. This cognitive pattern has precedent. In World War II, the Allies dismissed reports of German V-2 rockets because rockets capable of reaching London from Germany seemed technologically implausible. Early reports were attributed to exploding gas mains or conventional bombs. Only after repeated impacts and recovered debris did intelligence agencies accept that Germany had developed long-range ballistic missiles. The Allies' mental models of what was technologically possible delayed recognition of a real threat. With Atlas, we might be doing the same. Our mental models say interstellar objects are natural, so we interpret ambiguous data as unusual but natural rather than potentially artificial. Loeb's Trojan Horse framing challenges this complacency. It says, stop assuming, start testing. If Atlas is natural, intensive observation and analysis will reveal natural explanations for the anomalies. If it's artificial, intensive observation might reveal features that can't be explained naturally, geometric structures, industrial chemical signatures, radio emissions, something definitive. But we won't find those features if we're not looking for them. If we approach Atlas assuming it's a comet, we'll use comet models and explain away anomalies as cometary quirks. If we approach it as something that might be mimicking a comet, we'll look for evidence of mimicry. And mimicry leaves traces. The internal structure is key. A natural comet nucleus is solid ice and rock, irregular in shape with density around 0.5 to 1.0 grams per cubic centimetre. Atlas's estimated mass, based on gravitational perturbations during the Mars flyby, is at least 33 billion tons. For a solid ice rock object of that mass, the diameter would be roughly 2 to 3 kilometres. But observations suggest Atlas's nucleus might be smaller, which would make it denser. If the nucleus is 1 kilometre in diameter and 33 billion tons, the density would be around 5 to 6 grams per cubic centimetre, closer to iron than to ice. That's inconsistent with natural comets unless the composition is almost entirely metallic, which contradicts the spectroscopy showing ice and organics. Alternatively, the mass estimate could be wrong. Gravitational perturbations are subtle, and measurement errors are possible. But if the mass is significantly lower, say a few billion tons instead of 33 billion, then Atlas is far lighter than expected for its size. A 1 kilometre object massing only a few billion tons would have density around 0. 1 to 0.2 grams per cubic centimetre, which is aerogel territory. Natural objects don't have densities that low unless they're highly porous, almost entirely empty space with thin ice walls, or unless they're hollow. A hollow shell, thin walls with interior volume, could have any density depending on wall thickness. A metallic shell with walls a few meters thick and interior machinery could have the right mass and size to match observations while explaining the metallic emission and anomalous behaviours. This is speculative, yes, but speculation is warranted when data doesn't fit models. Science progresses by proposing hypotheses that fit data and then testing them. The natural comet hypothesis is being tested continuously, and it's struggling to explain the full dataset. The artificial probe hypothesis hasn't been tested rigorously because most scientists dismiss it a priori. Loeb's Trojan Horse framing is a call to test it. Not to assume it's true, but to treat it as a legitimate hypothesis worth investigating. The Greek soldiers inside the Trojan Horse waited until night. They didn't reveal themselves immediately. They remained hidden until the moment was right, until Troy's gates were closed and the city was asleep. If Atlas is a Trojan horse, if it's carrying systems designed to remain hidden until a specific moment, what is that moment? Perihelion might have been a test, activating systems briefly to see if we noticed. The December 19th Earth approach might be observation, getting close enough to study our planet in detail. Or the moment might not come until after Atlas leaves, transmitting data back to its origin civilization with no interaction with us at all. But there's another possibility. The soldiers might not wait for night. They might emerge in daylight if they determine the city is unprepared, if they realize the Trojans suspect nothing. If Atlas is monitoring our observations, analyzing our public discussions and scientific publications, it knows we're divided. It knows most scientists dismiss the artificial hypothesis. It knows our governments are only beginning to consider preparedness. If it has objectives requiring action while in the solar system, objectives like deploying sub-probes, altering trajectory for future return, or establishing communication, this moment of divided attention and institutional unpreparedness might be optimal. The horse might open before night falls, and we might not be ready. Now here's what the white paper actually says, and why it matters more than any television interview or social media debate. The paper, published October 31st, 10 days ago, isn't written for scientists. It's written for policymakers, people who make decisions about resource allocation, threat assessment and response protocols. And the central argument is stark. If there's even a 5% chance that Through-Eye Atlas is controlled, the potential consequences are severe enough that preparedness isn't optional, it's mandatory. The paper opens with historical case studies of black swan events, low-probability scenarios that materialized with catastrophic results because institutions failed to prepare. The 2008 financial crisis, the COVID-19 pandemic, the Fukushima nuclear disaster. Each event had warning signals that experts dismissed as unlikely. Financial models said housing markets couldn't collapse simultaneously across all regions. Pandemic preparedness plans existed but weren't funded adequately because pandemics seemed like distant theoretical risks. Nuclear safety protocols assumed natural disasters wouldn't exceed certain magnitudes. In each case, the unlikely happened, and the lack of preparation amplified damage. The paper argues that Three-Eye Atlas presents a similar dynamic. Most scientists believe it's natural, and they're probably right. But probably isn't certainty. If there's a 5% chance it's artificial or even 1%, the downside risk of being wrong justifies significant preparedness investment. The analogy Loeb uses in the paper is asteroid defense. We spend billions annually tracking near-Earth asteroids, even though the annual probability of a civilization-ending impact is only about 1 in a million. We do this because the consequence of not preparing extinction is unacceptable. For Atlas, the probabilities are far higher than 1 in a million that something unusual is happening, and the potential consequences, while not extinction level, could still be destabilizing. Section 3 of the paper, pages 5 through 9, analyzes Atlas's specific characteristics and why they warrant concern. It notes the object's mass, at least 33 billion tons, makes it the most massive interstellar visitor detected so far. Oumuamua was estimated at tens of millions of tons. Borisov was similar. Atlas is 3 orders of magnitude larger. If natural, this is scientifically interesting. If artificial, it suggests either a massive mothership or a probe with significant internal infrastructure. Either interpretation justifies heightened attention. The paper discusses the ecliptic alignment extensively. It calculates the probability that an interstellar object would naturally arrive with an orbital inclination below 2 degrees and pass within gravitationally significant distances of 3 planets over a span of 4 months. The combined probability is approximately 0.005%, or 1 in 20,000. The paper acknowledges this doesn't prove design. Low probability events happen. But it argues that when low probability events coincide with strategic advantages, design becomes a hypothesis worth testing rather than dismissing. Strategic advantages are key. If you wanted to design a trajectory for an interstellar probe entering our solar system, You'd align it with the ecliptic to maximize planetary encounter opportunities. You'd schedule encounters to enable gravitational assists, using planetary gravity to adjust velocity and direction without expending propellant. You'd approach during a period when observation from Earth is geometrically challenging, such as passing perihelion when Earth is on the opposite side of the Sun. Atlas's trajectory exhibits all these features. The paper doesn't claim this proves intent, but it notes that natural and designed trajectories produce different statistical signatures, and Atlas's trajectory is statistically more consistent with design. The thermal anomalies receive detailed treatment on pages 7 and 8. The paper cites the blue emission observed at perihelion, noting that thermal emission from a surface hotter than 5,800 Kelvin requires energy sources beyond solar heating. It reviews possible natural explanations, including subsurface heat from radioactive decay or exothermic chemical reactions, and concludes they're insufficient. Radioactive decay in natural bodies produces heat too slowly to raise surface temperatures significantly. Exothermic reactions, such as oxidation of metallic particles, could produce localized heating, but not the uniform blue glow observed across Atlas's entire visible surface. The paper proposes alternative explanations involving artificial systems. A fusion reactor with surface radiators would glow blue if operating at high power. Plasma exhaust from propulsion systems produces blue-violet emission. High-temperature industrial processes, such as metal refining or power generation, emit in the blue and ultraviolet. None of these proves Atlas is artificial, but they illustrate that artificial explanations fit the data as well, or better than natural ones. The paper argues that dismissing artificial explanations without testing them is methodologically flawed. Section 4, pages 9 through 11, addresses the Trojan Horse scenario directly. It defines a Trojan Horse as an object designed to appear benign or natural, while concealing capabilities that serve strategic objectives. It notes that reconnaissance is a common strategic objective for exploring civilizations. If an advanced civilization wanted to study Earth without revealing its presence, disguising a probe as a comet is rational. Comets are common, poorly understood, and rarely scrutinized beyond basic characterization. A probe mimicking a comet benefits from cognitive camouflage, blending into a category of objects observers assume are natural. The paper discusses detectability. A probe designed for stealth would minimize detectable signatures. It would use passive observation systems, cameras and spectrometers, rather than active systems like radar that might be noticed. It would maneuver minimally, only when necessary to achieve objectives, to avoid revealing control. It would mimic natural outgassing if it needed to adjust trajectory, making acceleration look like comet behavior. But stealth has limits. Maneuvers leave traces in trajectory data. Internal systems generate heat that might be detectable in infrared. Power systems might emit in radio frequencies. Perfect stealth is difficult, especially during high-activity periods like perihelion when solar heating provides cover for energy releases. The paper's policy recommendations begin on page 12. First, establish continuous monitoring. Don't rely on scheduled observations that leave gaps. Use multiple observatories to ensure redundancy. Track Atlas's position, brightness, and spectrum daily through its remaining visibility window. If the object deviates from predicted behavior, immediate follow-up observations are needed within hours, not days. Second, prepare contingency plans for scenarios where Atlas exhibits definitive artificial signatures. What is the communication protocol? Who has authority to speak for Earth? What message should be transmitted if the object appears to be waiting for contact? These questions have no current answers, and improvising during a crisis is dangerous. Third, avoid dismissing hypotheses prematurely. The paper notes that scientific conservatism, the tendency to favor familiar explanations over paradigm-shifting ones, is usually beneficial. Most unusual observations have mundane explanations, but conservatism becomes bias when it prevents consideration of legitimate alternatives. For Atlas, the artificial hypothesis has been dismissed by many scientists not because data rules it out, but because it challenges assumptions about our uniqueness. The paper argues that evidence, not assumptions, should drive conclusions. Fourth, engage internationally. Atlas is a global issue, not a national one. If the object is controlled, its operators might observe all of humanity, not just one nation. Responses should be coordinated through international bodies like the United Nations Committee on the Peaceful Uses of Outer Space. Unilateral decisions, such as one country attempting communication without consulting others, create diplomatic risks and might send mixed signals to any observers. The paper's conclusion, page 14, is blunt. The city of Troy fell because its guardians trusted appearances. They saw a wooden horse and assumed it was harmless because it looked like something they understood. Modern civilization has better tools and more knowledge, but we're vulnerable to the same cognitive trap. If Three-Eye Atlas is natural, our caution will seem excessive in hindsight. If it's artificial, and we fail to prepare because we assumed it was natural, the consequences could define our generation's legacy. Preparedness is cheap compared to the cost of being unprepared. The paper circulated rapidly through policy networks. By November 5th, 5 days ago, copies had reached key decision-makers in the United States, European Union, China, Russia and Japan. Whether it influenced policy is unclear. Governments don't publicize deliberations about hypothetical alien probes. But there are indicators. NASA's Planetary Defense Protocol remains active 12 days after perihelion, longer than typical for objects that pose no collision threat. The International Asteroid Alert Network continues coordinating observations with intensity normally reserved for impact threats. Radio telescope facilities have allocated observation time in December, focused on detecting potential transmissions from Atlas. These actions suggest that even if governments aren't publicly endorsing the Trojan Horse hypothesis, they're quietly preparing for it. Avi Loeb's co-authors also matter. Omer Eldadi brings expertise in spacecraft navigation and orbital mechanics. His contribution to the paper includes trajectory analysis, showing that Atlas's path is consistent with optimal gravitational assist sequences. He calculated that if the object performs a small maneuver during the December 19th Earth approach, it could redirect towards several promising future destinations, including a return to the inner solar system in a decade or a trajectory toward nearby star systems. These calculations don't prove intent, but they show that Atlas's current path positions it well for future maneuvers if it has the capability. Gershon Tenenbaum's psychological perspective is equally important. His section of the paper discusses how institutions respond to ambiguous threats, particularly threats that require paradigm shifts in thinking. He cites studies showing that organizations underreact to unprecedented threats because existing protocols and mental models don't include categories for the new threat. Before 9/11, aviation security focused on hijackers demanding ransom or asylum, not suicide attackers using planes as weapons. The mental model didn't include that category, so warning signals were dismissed as noise. Tenenbaum argues that Atlas presents a similar challenge. Our mental models include natural interstellar comet, but not artificial interstellar probe disguised as comet. Signals consistent with the second category get interpreted through the first, and anomalies are explained away rather than investigated. The paper has critics. Several astronomers published responses arguing that Loeb is overstating the case. They note that each anomaly has potential natural explanations, even if those explanations are speculative. The blue color could be emission from rare molecules not yet detected spectroscopically. The acceleration could be outgassing from jets too faint to image. The trajectory alignment could be statistical coincidence. Extraordinary claims require extraordinary evidence, and the evidence so far, while intriguing, doesn't meet that threshold. Publishing alarmist papers risks damaging public trust in science and distracting from legitimate research. Loeb's response is that the paper isn't alarmist. It's not claiming Atlas is definitely artificial. It's arguing that the artificial hypothesis deserves serious investigation because the data is ambiguous and the stakes are high. Dismissing the hypothesis without investigation is the real failure of scientific rigour. Science advances by testing hypotheses, not by assuming some hypotheses are too unlikely to test. If Atlas is natural, rigorous investigation will confirm that. If it's artificial, only rigorous investigation will reveal it. Either way, investigation is warranted. The debate will continue through December and beyond. But the white paper accomplished its primary goal, legitimizing discussion of the Trojan Horse scenario at policy levels. Officials who want to prepare for the possibility that Atlas is controlled now have peer-reviewed justification. The paper provides cover for allocating resources, scheduling observations, and developing contingency plans without appearing to pander to fringe speculation. Whether those preparations prove necessary depends on what Atlas does over the next 39 days, and whether the wooden horse opens its doors. Now here's where the timing becomes impossible to ignore. Perihelion occurred on October 29th, 12 days ago. Halloween fell 2 days later, October 31st. And the symbolism is so perfect it feels deliberate. Halloween is the holiday of masks and costumes, of things pretending to be what they're not. Children dress as monsters that aren't real. Houses display decorations that mimic danger without actual threat. The entire cultural practice revolves around deception, disguise, and the blurred line between appearance and reality. And on that exact day, the day dedicated to costumes, we learned that Atlas had done something at perihelion that looked very much like it was wearing one. Loeb didn't choose October 31st for symbolic reasons. The white paper was ready when peer review cleared it, and publication timing followed journal schedules, not holidays. But the coincidence resonates. When data from solar monitoring satellites was analysed and released on Halloween, showing Atlas's blue glow and unexpected acceleration, the timing amplified the Trojan Horse narrative. Social media exploded with memes comparing Atlas to a Halloween costume, a comet mask hiding something underneath. The metaphor was too perfect to resist, and whether by design or accident, the Halloween timing ensured maximum attention to Loeb's warning. The 2-day gap between perihelion and Halloween is also significant. Atlas passed closest to the Sun on October 29th, exhibiting its most dramatic anomalies while Earth was on the opposite side of the Sun, unable to observe directly. Solar monitoring satellites captured the events, but ground-based telescopes, with their superior resolution and spectroscopic capabilities, were blind. By the time the data was analysed and we learned what happened, the moment had passed. Atlas was already moving away from perihelion, cooling, returning to more stable behaviour. We missed the critical moment when whatever systems activated at perihelion were fully visible. All we have are the indirect observations from satellites designed for solar physics, not comet studies. This observational gap raises questions. Was it coincidence that Atlas's perihelion occurred when Earth couldn't observe it directly? The object's trajectory has been calculable since discovery in July. Anyone with basic orbital mechanics software could determine that perihelion would happen on October 29th, and that Earth would be poorly positioned for observation. If Atlas's trajectory is designed, was this timing deliberate? Did the designers choose an approach path that places perihelion during solar conjunction, ensuring the most critical phase occurs when humanity's best telescopes are blind? Or is this paranoid pattern matching, seeing intent in randomness? Loeb addressed this question in a November 5th interview 5 days ago. He noted that the geometry is suggestive but not definitive. If you're designing a reconnaissance mission, you'd want to perform high-energy maneuvers or system tests when observation is difficult. Passing behind the Sun provides natural cover, but you'd also want to approach when observation is easy if your objective is communication. The fact that Atlas's perihelion occurred during poor observational geometry suggests stealth over communication, but it could also be coincidence. The solar system's geometry is deterministic. Any interstellar object approaching from certain directions will pass perihelion when Earth is on the far side. Atlas happened to approach from one of those directions. The December 19th approach, 39 days from now, has better geometry. Earth will have moved in its orbit, and Atlas will be visible in the pre-dawn sky. well positioned for observation. This is when Hubble, Webb and radio telescopes will focus on the object intensively. If Atlas is a Trojan horse, December 19th is when the doors might open, not necessarily revealing soldiers but revealing something, a manoeuvre that can't be explained naturally, a transmission that indicates communication, geometric structures visible in high-resolution images, something definitive. But what if December 19th comes and goes and nothing happens? What if Atlas behaves exactly like a comet, showing no further anomalies, and then fades into the distance as predicted? Does that prove it's natural, or does it prove the disguise worked? This is the trap Trojan horse scenarios create. Negative evidence, the absence of detectable artificial signatures, doesn't confirm natural origin. It only confirms that if the object is artificial, it's good at hiding. You can't prove something isn't a Trojan horse by observing that it looks like a horse. That's what Trojan horses are designed to do. Loeb's argument is that we should prepare for both outcomes. If Atlas reveals itself on December 19th, showing clear artificial signatures, we need protocols for response. Who communicates? What do we say? What if the object responds? These questions have no current answers because humanity has never faced this scenario. SETI protocols exist for detecting signals from light years away, but those protocols assume decades of debate before response becomes relevant. If Atlas is only 267 million kilometers away and capable of maneuvering, response timelines compress from decades to days. If Atlas doesn't reveal itself, if December 19th passes with nothing definitive, we still learn something. We learn that either it's natural or it's artificial and very good at hiding. Both possibilities have implications. If natural, we've overreacted, but the cost is minimal and the experience improves our protocols for future interstellar visitors. If artificial and hidden, we've been evaluated by an intelligence capable of reaching us, observing us, and departing undetected. That evaluation might inform future contact, or it might mean we're considered uninteresting. Either way, we'd know we're not alone. The policy implications of the Trojan horse scenario extend beyond Atlas. If interstellar probes can disguise themselves as natural objects, how many have we already missed? How many comets observed over the past century were actually reconnaissance missions? Halley's Comet returns every 76 years, visible to naked eye, studied extensively. Could it be artificial? Almost certainly not, given its predictable orbit and well-understood behavior. But Oumuamua in 2017 was the first confirmed interstellar object, and it exhibited anomalies, accelerating without visible outgassing. Loeb proposed it might be artificial, a hypothesis most scientists rejected. But what if he was right? What if Oumuamua was a probe and Atlas is a follow-up? This raises uncomfortable questions about disclosure. If governments determine Atlas is artificial, do they tell the public? The geopolitical implications are enormous. Confirmation that extraterrestrial intelligence exists and has visited our solar system would destabilize religious institutions, challenge philosophical assumptions about humanity's place in the cosmos, and potentially trigger panic or social upheaval. Some argue that governments would suppress the information, either claiming Atlas is natural or releasing data selectively to avoid panic. Others argue that in the age of social media and distributed observation networks, suppression is impossible. Amateur astronomers will observe December 19th. If they detect anomalies, the information will spread regardless of official statements. Loeb has argued repeatedly that transparency is essential. Suppressing information creates conspiracy theories and erodes trust. If Atlas is artificial, the public deserves to know. Humanity collectively faces the implications, and collective decision-making requires shared information. But transparency also requires responsibility. Information released should be accurate, contextualized, and not sensationalized. Announcing, "We've confirmed alien technology," based on ambiguous data would be irresponsible. But announcing, "We've detected behaviors inconsistent with natural models and are investigating," is both honest and appropriate. The 39 days between now and December 19th are a countdown, not just to Atlas's closest approach, but to a potential revelation. Every night that amateur astronomers observe the object starting tomorrow on November 11th is another data point. If Atlas brightens unexpectedly, if its trajectory shifts, if spectroscopy reveals new anomalies, these events will be documented in real time by a distributed global network. The days of governments controlling information about cosmic events are over. Atlas is being watched by thousands of people, professional and amateur, across 6 continents. If something extraordinary happens, we'll all see it. And if nothing extraordinary happens, if Atlas fades into December and then disappears, leaving us with unsolved anomalies but no definitive answers, then the Trojan Horse hypothesis remains what it is now, plausible but unproven. The debate continues. Scientists will argue about interpretations for years. Some will insist natural explanations exist even if undiscovered. Others will point to the accumulated anomalies and argue that artificial is the simpler explanation. The data won't change, but its meaning will remain contested. Loeb's legacy might be forcing the question into mainstream discourse. Before his Fox News appearance 8 days ago, the artificial hypothesis was fringe, discussed in blogs and YouTube videos but not in policy papers or congressional hearings. After the Trojan Horse framing, the hypothesis is on the table. It's being debated in op-eds, discussed in university seminars, mentioned in government briefings. Whether Atlas is natural or artificial, Loeb has succeeded in making the possibility that we're not alone a legitimate subject of scientific and policy discussion. If you've stayed with this journey through warnings, white papers, and the implications of wooden horses arriving from the stars, consider liking and subscribing for more deep dives into the threats we might not recognize until they're inside our walls. Share your thoughts in the comments about whether Loeb is right to warn us, or whether the Trojan Horse analogy goes too far. The countdown is running. 39 days until December 19th. 39 days until the closest approach. And if Atlas is a Trojan horse, 39 days until the doors might open. The Greeks waited until night. But we don't know what Atlas is waiting for. We don't know if it's waiting at all. We only know that appearances deceive Troy, and Loeb is warning they might deceive us too. Sweet dreams.